I think we should start. We'll keep letting people in, but yeah. Uh,
I just shared my screen, if that's okay. Can you hear me? I think you could not hear me.
Yes. I can hear you. We just quickly go over introductions and.
Yes, absolutely.
Hello. Welcome to a talk arranged by the Theory Club. The Theory Club is a student-run organization on the campus of St. Xavier's College. We have been operating completely online this year due to the pandemic, and one of the reasons why we are going to have this talk today is because the vaccination drives have started, and we thought that the students on campus would like to know more about the vaccine and vaccination as a science in general. Today we have invited Sandhya Koushika, who is a professor at the Department of Biological Sciences at the Tata Institute of Fundamental Research. She's a faculty member there, and she's a cellular neurobiologist. She uses the worms C. elegans to do various neuroscience research. If you haven't been to her lab, I highly recommend you visit TFR on National Science Day. On National Science Day, they have the labs are open, and some of our PhD students will kind of guide you through what kind of work they do, and it's spectacular, and it's a lot of fun to go there every single year. It's a pleasure to go. For today, she's going to tell us more about the vaccine, because she has been involved for the past few months in the popularization of scientifically accurate information about COVID through COVID Gyan, which is a website set up by a collaboration of scientists in India, as well as the Indian scientists' response to COVID, which is also a collaboration to dispense scientifically accurate information about COVID. So, without any further ado, let's start. Ma'am, you could start with the presentation.
Can you see my slides?
Yes, they are visible.
Okay. So I'm less familiar with the Google Meet platform, so I was not completely sure. Thank you very much for inviting me, and I hope please feel free to interrupt and ask questions, or if you have questions at the end, I can stay behind and we can chat about things. I am, of course, as he introduced me, a neurobiologist, and anything that I have learned about immunology or viruses, apart from generally being interested in infectious diseases and public health issues, has really been over the past year. I think I gave my first talk on COVID-19 in Chai and Wai end of March of last year, and we've certainly it sometimes feels like a very long year with a lot of things going on. And I'm sure as students you have tremendous disruptions in your life. So let's start off by just looking a little bit, and I read this when it first came out, and I still find it a very interesting BBC story, which gives you a little bit of a history of vaccines and vaccinations in India. This is a picture which was put up for auction in Sotheby's. And the person who is, a historian looked at it and said, "Oh my God, this is a picture of the Mysore Queen." And she is showing her arm because essentially she is trying to show to the people that she has been vaccinated. And the Queen Mother had lost her husband um, when to smallpox, which was then and throughout history, we've had numerous infectious diseases, a very, very deadly disease. And I think she didn't want her son, who was the king, or her daughter in law to have the disease. And so, she got her immunized against smallpox. And at that time, by the way, interesting, the year was 1805 was when they were married. So it has to be a few years after that. When she got married, she was around 12 years old. So definitely more than, 200 years ago. And you see that immunization against infectious diseases was very, very important. And also you see through the power of this picture how important it is. Today we have celebrities and leaders of countries showing that they're getting vaccinated. And you see the power of that even at that time, many, 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 couple of hundreds of years ago. Okay, so let's get started about a little bit of the history of smallpox in India. Smallpox has been known in people for a really long time, right? We've all, I think, get vaccinated. You're young, we've eradicated this disease, you don't get vaccinated against smallpox. But people did get until the, early 80s, I think, get vaccinated against smallpox in India. And smallpox itself is supposed to have been believed to have been originated from India or Egypt. And there's a description of smallpox in Sanskrit literature. The second thing, that just tells you that this is such a terrible disease. It's been around for a long time and people have sort of recognized the value of it. So, there are very, very old descriptions of inoculation attempts made to protect populations. So there are essentially two ways in which you can immunize populations. One is what we do now, which is called vaccination, and the other is called variolation or inoculation, where you take live agents and sort of seed it into human beings. And therefore the people or the tikadar or the person who's delivering the vaccine has to be an extremely skilled practitioner. Otherwise, if you give too much, the person is going to essentially die, right? So those were, in fact, those practices of variolation and inoculation were done in India. They were done in other countries as well. And in fact, this practice was described by Dr. Hovell, who had heard about it, as a practice that could perhaps be thought about in the context of the UK, because smallpox was a disease that was present throughout the world. Okay, so fast forward from there, and the first actually experiment was done by Benjamin Jetsi, not Jenner, which all of us hear about in school textbooks, an experiment on his wife with 2 children by injecting cowpox matter. And this is a fairly rare thing to happen, right? That you take cowpox and then you get some sort of protection against smallpox, which is a similar but a very different bug. This idea was picked up by Jenner, and of course, then went on to have this famous observation with milkmaids, and then ended up having vaccine production, now immunizing or rather vaccinating with cowpox rather than smallpox. There were, of course, formidable challenges because you have to keep the cowpox alive as you went from country to country, city to city. And sometimes you would have a live carrier of the smaller, of the cowpox. You infect someone and then take some of those pustules and try to move it around. And you have to remember there was no planes, it was all by ships. So it took time. The first documented smallpox vaccination in India was around 1802. And what ended up happening, that was, of course, British India, is that they decided to ban the practice of variolation or inoculation because they felt it was very dangerous. This was, of course, very resisted. And the reason it was resisted was because there were all these tikadars who were essentially medical professionals and who got paid and their livelihoods was taken away. In fact, what British India did was started employing people who would do vaccinations, but it was not necessary that they took the tikadars and make them, vaccine deliverers, because, they had a special and a different status in society. So certainly you see early on the push and pull, the push between the science and society with respect to protecting and executing on an immunization program is very old, and there has been resistance to these efforts from time immemorial. Okay, so I already covered some of those reasons. There was, in fact, I'll show you the next slide, is when you come on to later during the vaccination, for many of us is a routine thing that, all young children get vaccines and you don't think twice about it, right? But to get that kind of acceptances, there were many approaches used. There were approaches used where you had these kind of posters which were saying that this is the pox goddess, you need to appease her, you need to pray to her. And in fact, there were things which were done in the early 1900s, where if somebody still got smallpox, or they would tie something outside the house and everybody in the community would know, they would know to keep them isolated until such time that all their sores and everything had dried up and fallen off, or they had recovered. So, this idea that there was something which was responsible, there was also God who was responsible, this is India, of course, and that you need to isolate people so that it doesn't spread in the community, were very old ideas which you've sort of forgotten because it's been 100 years since, or close to, or where we had to worry about such things. You also saw a little later on these kinds of posters where they tell you, it's really saying, inform at once. Do you have smallpox? This is how it looks. Go to your health center. You have fever and rash. Get it treated. Don't let it spread, right? And in fact, when you had, and here, this is an excellent graph to look at. You had in India, this is the outbreaks of smallpox, and you had around 73, 74, a really, really large outbreak of smallpox. And the way it was controlled, and it was regional, it was not across the entire country, was something which is called ring vaccination. That is, you go around an infected population and everybody around it you vaccinate, so that you break the chain and you don't allow the spread from that region to outside that region. Of course, you realize that this is going to have to come hand in hand with some sort of containment. And of course, I think it was 1977 that India was declared smallpox free, and not to, it's a huge public health effort. And we were also declared polio free at some point. And so, we've had notable successes in India in vaccinating and protecting our populations, and some failures as well. Okay. One thing which is very, very clear is, and this is a picture which came from The Economist, which I particularly liked, and when I first read it, and I've sort of hung on to it now for, I think, few talks, is that deaths decrease with vaccination, right? For every statement that a scientist make, you want to have some sort of evidentiary support for it, and here is, some historical examples. Here's smallpox deaths in London, and you see it goes all over the place, right? Goes up, goes down. Yes, certainly there's an outbreak, there are many more cases. It never falls to zero. You always have some amount of cases present. Once you started deaths present. Once you introduced the cowpox vaccine and the use of it picked up, you see slowly it begins to decrease. Vaccination is banned. In-fact, vaccination becomes mandatory, and the Franco-Prussian War causes an epidemic. And what happens in the Franco-Prussian War? There are lots of people present in close quarters with each other, and it's probably very, very difficult to do anything which promotes good public health in that situation. Right? You see the same thing with polio. Soon after the Salk vaccine was introduced, the number of deaths from polio just dropped. Same thing with the measles in Nigeria. You have a nationwide immunization program in 2005. Drops. Don't have enough vaccines. Gavi Alliance supports more vaccination effort because vaccines and public health mandates are expensive, take a lot of effort, and are something that the government needs to commit to. And sometimes you get help from, in this case, from Gavi. And you see, again, there is certainly an effect. And the deaths have stayed fairly low ever since vaccination was introduced compared to what happened earlier. The data strongly support that with vaccination, you can reduce deaths. Vaccines work and have impact in multiplicity of cases, not just death, right? One of the questions I was asked, it's still actually a very good question. Said, what happens, why can't you have just improvement with public health measures? And you have good toilets, you have flush toilets, and once hygiene improves, public health should improve. And there's not a whole lot more you can say. It need not accrue just to vaccines. Is that true? So let's look at one example, chickenpox. Look at 1980. And this is looking at the United States. Okay, we're not looking at any other country. 1980, hygiene was just excellent in the United States. There was no problem. You were not, you were not pumping water somewhere else and not able to keep yourself clean. Does not even exist, right? And yet you have a large number of reported cases. The size of the circle is the number of reported cases. 1995. Chickenpox vaccine is licensed and added to routine childhood vaccination. And just look, it's a dramatic drop and stays low. So the number of cases really stay low. Yes.
And the screen is not shared.
Screen is not shared?
Ma'am, it's visible to some people, but I think the people who have joined now, it's probably not visible to them. So can you please reshare it?
Absolutely. So I didn't know that even happened. Okay. I apologize. As I said, stop presenting. Okay. Can you see it now?
Yeah, ma'am, now it's seen.
Okay, excellent. Thank you. And I get my laser pointer. So if you're asking about public health alone being important, and public hygiene and general improvements in hygiene being important, the chickenpox vaccine is an excellent example. Now, I think it's important to recognize, and perhaps now all of you young people who are in this talk recognize this, that what's really, really important here and now is not only deaths, right? When people fall ill, there are burdens and difficulties placed on the healthcare system. There are difficulties placed in families. Difficulties placed in families in allowing all its members to devote time to work or to their pursuits. And there is a large number of issues of health-related recovery times which impact the family, including medical costs. Therefore, having these kinds of public health measures bring benefits to society which are long-lasting in terms of the health of young people, the ability of older people to absorb their caregiving duties without hurting them financially. And those sorts of impact are not something which is very easy to quantify through this slide, but that's estimates have been made, and they're very, very valuable, and the benefits are very large. So that's something to keep in mind, because often we sort of frame the debate saying that it's only death. It's way more than death. Okay, so let's look at COVID, right? We all know that COVID is not supposed to be such a dangerous disease. Very few people die and most people recover, and that still seems to be true. Okay, let me see if I can actually hide this. Okay, so what happens here when you recover from COVID. And this is something to, again, I would like young people who are, I assume most of the audience today, who will, if they ever get infected, recover well, to consider these pieces of data that have come out. 6 months after recovering from COVID, this is the distribution of symptoms that you see. 6% of the people had at least one symptom. 63% had fatigue or muscle weakness. Some number had sleep difficulties. 15 to 20% had anxiety or depression. Of course, these may not be directly associated with the disease. It could arise from issues surrounding what has happened after you're ill. But what's striking to me was 50% had lung abnormalities. So it's not as if even though you recover, you're restored to the way you were before. And that's very important to keep in mind with this disease. The control strategies, they haven't changed. It's still masks, guys, and well-fitting masks which cover your nose and mouth, because you need that. Ventilation is hugely important. So when you're in indoor spaces, your chances of, especially poorly ventilated spaces, you are going to have far greater difficulty in protecting yourself unless you're masked. And it's, of course, better to layer on more and more protective layers. And we'll come to that, the Swiss cheese model of protecting yourself. Distance and hygiene. Containment has always been the name of the game. And one of the slides which I put somewhere here is how many cases are there in the world, how many cases in India. And I feel like this time I didn't even put it because it's very depressing. And I'm just not even going to do that. I think we all know it. It's there in every news channel you look at. Anytime you open Twitter or any social media platform, that's the name of the game. So I think we know the numbers and we need not worry about it. But the main strategy has always been test, trace, isolate, and then treat. And treatment, have some miraculous treatments. Dexamethasone seems to work at certain times to reduce death. There are some experimental monoclonal antibodies, but sometimes we have immune escape from them, and increasingly that's being discussed. The IL-6 receptor antagonist of the combination of tocilizumab and sarilumab, and of course vaccines. I just want to say right here that vaccines are not a panacea. They're not 100% protection. You have to add them, layer it in top of these other ways of mitigation, which is masks, ventilation, etc. But if enough people are vaccinated, then we have a chance to break the chain. To that again. So I just thought I would spend a little bit of time telling you about how the body responds to any bug that comes into you, any virus or bacteria. You first have your innate immune response, your cellular immune response, which will actually sort of, some cells will take up the virus, or some bacteria will attack some cells. And then there is a local response given by that cell which get infected, which then attracts some of the immune system cells. Then if that innate immune response is not able to control the viral load and the virus just is able to replicate and escape that initial response, it's at that time that the adaptive immune response kicks in. Innate immune response is an old evolutionary strategy present in fruit flies, present in C. elegans, which I work on in my lab, to fight off predators, right? But the adaptive immune response is not that old, and it is actually tuned to fight off a particular kind of predator that you face, a particular kind of bacteria or a particular kind of virus, for instance. This is a beautiful video, and since I think you guys are streaming it on YouTube, perhaps it is possible that you will have access to this later on, and I urge all of you, especially if you're interested in biology at all, and even if you're not, if you're interested in COVID right now, which has taken over our lives, to watch this video. It gives a very simple explanation of how the immune system works, right? So as I said, the virus will come in, it'll sort of eat up, it will infect one particular kind of cell. This cell produces interferons, and these interferons do multiple things. They can put signal to neighboring cells to put up barriers because they're secreted. They signal the infected cell to die. And sometimes when they die, they release more of these kind of interferon-like particles and molecules. And then it can recruit WBCs to stimulate long-lasting immunity. Actually, what happens, virus enters, and I think right now everybody knows about the spike protein and double mutants and things like that. I'm happy to take questions later about it if you would like. There is an enzyme on the surface of the cell which cleaves the spike protein, cuts the spike protein, allowing it to unfold and then be able to attach much more effectively to the ACE2 receptor. It enters the cell. Once it enters the cell, have this RNA get replicated and then form new viral particle which can be shed from that cell. And this kind of shedding which happens is what leads you to release from your mouth, from your nose, as you talk, as you sing, as you even exhale, viral particles into your environment. And if you put a mask, you capture those viral particles. But they're essentially the product of your hijacked by the coronavirus or any other virus for that matter, and then replicate and send that out through your airway passages. When you have these viruses circulating in your body, what ends up happening is you have something called the antigen presenting cell, which is part of the immune system, that eats up this virus, presents it little proteins which are called MHCs. They attract the T helper cells, and the T helper cells in turn work with the B cells to make antibodies, the same thing which gives us seropositives and things of that nature that all of you have heard about, but it also sort of acts to stimulate and works with the cytotoxic C cell, and this T cell will actually can go and kill cells which novel coronavirus. So both these arms, you have the early as well as the memory, and then later on these cells you'll have some number of memory T cells and memory B cells. When you think about memory cells, you must have heard about the waning immunity in people, right? The people who got infected in the first wave, we're finding 7, 8, 9, 10 months later, you're finding about 20-25% of the people are not seropositive anymore. In fact, there was a new study which is going to come out from which has done such a survey and say there's waning immunity, and there will be data that comes out from Mumbai as well, where you'll see this waning immunity and a fourth of the people or some fraction of the people are not seropositive anymore, and there's this reduction. That just means they don't have circulating antibodies. And this is from the SARS epidemic, which was about 17, 18 years ago. 17, 18 years after the fact, you have memory T cells, which are capable of going and killing cells which are infected with the coronavirus. 17, 18 years after your infection, where you recovered from SARS, where basically something like 20% of the people who got infected with SARS died. This is COVID-19, which is SARS-CoV-2. It's much lower. So you have these memory T cells that are present for a very long time. Your memory B cells will be primed if you get a new infection to make antibody again. There are issues. The one will come to the end about things like vaccine escape, and we'll discuss that maybe in the question answer. I won't spend a whole lot of time just in the talk. Your non-specific response is the innate immune response, which starts first. You have the infection, and then you have both specific memory cells and B cells which make antibodies, and T cells which go and kill infected cells. And as I've already said, these can last for years. We still don't know for SARS-CoV-2, that is for COVID, how the body responds against COVID-19. Will we have the same kind of long-lasting immunity if we get infected or if we get a vaccine? That still needs to be studied, because the disease has been around for a year and few months. So we're not going to have those answers very quickly. And it's in a moving pandemic. As the data comes out, scientists are putting it out in in bioRxiv and medRxiv, allowing all of us, in fact, to see that data as it comes out, and eventually it gets through the review process and gets published. But we don't have enough time yet for us to know these things. These are research questions which will be looked at over time. So what I will do is I will skip. Okay, maybe I should go through this. It's actually very important. What do you do when you're getting a vaccine? Because what I actually described was what happens when a real bug gets into your body or the real coronavirus gets into your body. A vaccine is completely different, right? It's given, you're not getting infected by a live coronavirus. You're getting infected by an attenuated coronavirus or an inactive coronavirus, or you're getting vaccinated with a small fragment of the protein which is present on the coronavirus's surface. This, when it is injected into the muscle or whatever is the route of administration that particular vaccine has chosen, what you see is that those antigens stimulating your immune response will again go into your antigen presenting cells, will show up on its surface, and then do the same thing. Recruit the T helper cells, get one arm which is going to be the antibody producing arm, and the second arm which is going to be the cellular killing arm, right? There's several things a vaccine contains. It contains preservatives, it contains emulsifiers, it contains stabilizers, it contains adjuvants to improve immunogenicity. One of the oldest adjuvants is alum, which used to be, if you might have never done that experiment, but if you have muddy water and you put alum, it would allow the muddy water to settle down because it would sort of bind it. Newer adjuvants. In fact, alum is still used as an adjuvant for many vaccines. And there's constant innovation happening in these states, in these spaces to get a better adjuvant. Let me give you an example. Diphtheria. The toxoid that the diphtheria bug produces is what leads to problems for a person who gets infected. The first round of vaccinations that you did with the diphtheria toxoid was not long lasting, essentially because it did not stimulate a strong immune response. They could use an adjuvant and deliver it with the adjuvant, you now got a much stronger immune response. And now anti-diphtheria vaccine is part of routine childhood vaccinations given to everybody in India. There are many, many old and newer technologies of vaccines. The old technology is the live attenuated, weakened, or inactivated, which was what was used for smallpox. Even for the variolation, you would try to pick from people so that you could titrate how much the individual who got vaccinated got, so they did not get a very severe disease, right? And that's where the tikadar played a huge role. You can have a killed whole organism, like was done for typhoid, or I already told you the story about using toxoids conjugated to an adjuvant, which was done for diphtheria. And you can have subunit vaccines where you take different subunits which come from the viral surface or the bacterial surface, take those proteins and use those proteins as a means to immunize. So there are many, many technologies, some which are very old, and some like the mRNA. I can't imagine there's anybody in this group who hasn't heard of the mRNA vaccine from either Pfizer or Moderna, which was first developed in 2019 for Ebola, and of course was used in a very, very restricted manner, and now is being used in large number of countries, the United States and Canada, Israel, etc., where it is the mainstay of the vaccination program. Right? And the DNA vaccine is the newest one to come out. It's being developed now, and actually in India, Zydus Cadila is in phase 3 trials with the DNA vaccine. And we're going to hopefully by the end of the year have some data and have the vaccine for public use in India, which is the newest technology where there is. Right? So different types of vaccine technologies. A little bit of time talking about why is vaccine safety important. Vaccine safety is important because it's given to healthy people, right? It's not given, when medicine is given typically to sick people. So if you're very sick and you want to treat them, anything you give, even if it is a side effect, it makes them better. That's great. They got better. Yes, they had a few side effects. But what do we do with vaccines? We give them to healthy people. So when the Pfizer vaccine started having, people having severe allergic reactions, they were 12, initially was thought of as 12 events in a million. It's come down to 6 or maybe 4 events in a million. It was still of concern. It's very, very low as a fraction, but still given to healthy people. You don't want healthy people to fall sick. It needs to have very high efficacy, right? It needs to have very high efficacy, is that it must actually do the job it says it's going to do. Does that mean it protects you either from infection or protects you from disease or protects you from death? What is it that that vaccine does? So we need that information. This is very different from effectiveness, and I'll come to that. It's given to a wide range of people, especially in this pandemic, with varied health and varied ages. These are not childhood vaccinations given only to a small number of children, and even their children also, when they are just born, could have different health profiles, right? So harmful to them either. Typically, multiple doses are given. The first dose might cause no reaction. The second dose might cause a bad reaction. So every dose that you're given should not lead to adverse effects. The other practical things, quality of production, distribution, storage, ease of administration are all very important. For instance, the Covaxin vaccine did not get approved in Brazil, and one of the reasons given was that we are not sure that all of your production facilities are to the same standard. So unless we are sure of that, we don't know from which facility you're going to get it, and we are not going to approve this vaccine in Brazil, right? So there are those issues, because every single batch of the vaccine has to be exactly what you said it was. People in this world have vaccine hesitancy. In fact, what was striking when January we started rolling out Covishield in India for healthcare and frontline workers, I'm not sure, there was a large number of people who were young frontline workers and healthcare workers who said, because at that time, these cases had started coming down. They said, we don't need the vaccine. We're not going to take it. They were in their, late 20s, early 30s. And that hesitancy exists. And these are the people who actually would bear the brunt of any sort of surge that we are going through, because whatever happens, the most sick people end up in hospitals where frontline workers have to take care of them, right? So even in that group, sometimes people have vaccine hesitancy. So it's essential that vaccines must work as advertised. As I said, there are many technologies. There's inactivated and live attenuated. There's DNA, there's RNA, there's the adenovirus, which is the Covishield or AstraZeneca, virus-like particles, soluble proteins. And, in each slide, I have put references in. So if you would like to read further, access to it, hopefully from the YouTube channel. And I'm happy to email you this presentation as well. So let me spend a little bit of time, in case you're not familiar, about the pathway to make a clinical trial. The first thing that you do is a phase 1 trial, right? And the only purpose of a phase 1 trial, which may be very small number of people, less than 100 people typically, and you ask just one question: is the vaccine safe? Are there any serious side effects? If I give half a dose versus a full dose versus twice the amount of dose, is there something that I'm seeing which is an adverse reaction? What would be an adverse reaction? It would not be chills or a little bit of fever or, some diarrhea. No, it would be something that I can't walk, I can't breathe. Oh my God, I'm not able to move. Those are very serious when your quality of life is completely upended for a long period of time, right? So those are very, very, very serious side effects that you watch out for with a small number of people. Once you have seen that, you go to phase 2. And both in phase 1 and phase 2, you try to see if you provoke an immune response. Do you see an immune response, or is it immunogenic? That is, what is your immunogenicity? Your phase 2 is about 1,000 people. It's usually not more than that. It's a few hundred people. And then you tabulate over here what are your most common side effects. Is the immune system responding? Is there some sort of immune reaction that you're seeing? Are there some antibodies maybe being produced? That's what you do. Think about what I talked about the AstraZeneca, about the Pfizer immune reaction. 6 cases in 1 million people had a severe allergic reaction. You're not going to catch that in phase 2 unless you're extremely lucky, right? And you want that number to be almost 0. And you can sort of see that from the kind of reaction and worries that are happening with AstraZeneca, which we will come to. I actually have slides about that, about the AstraZeneca vaccine, which is Covishield. Once you know that you have immunogenicity and it seems to be safe, then you go to the next phase, which is the phase 3, which is typically under 10,000. And in a pandemic, sometimes you have to have 30,000 because there'll be populations of people who have had the disease. There may be, you don't know what the local spread of the disease is. You don't know how many people are seropositive and have protection already. So if you have to assess all these things, you need to actually look at a large number of people, right? So you look at something like 10,000 people and you ask, arm who are given a placebo, what number of people fall ill, get hospitalized, even or just test positive for COVID-19. And in the second arm, you say, I've given the vaccine. Now let's get the same data for that. And it's based on both of these arms. You come up with numbers for efficacy. So for instance, what we now know is for the Covishield or AstraZeneca, even the first shot gives some degree of protection. Whereas Sinovac, which comes from China, was one of the major vaccines used in Chile, gives only 3% protection after the first shot, right? So that's not much protection. That means you really essentially gives you no protection at all. Your individual risk of contracting COVID is, your individual protection is very small. So if you say your efficacy is 80%, that means that there's an 80% chance that you will not get bad outcomes. And in the COVID-19 vaccines, they all mean not get bad outcomes. That is, you can still get an infection, but death is 100% protection or close to 100% protection if you have the full dose of the vaccine. At least so far, that appears to be the case. And so far, that seems to hold true. That means you need both doses and some time after the doses have taken. So if you looked at those charts of immune reaction that I showed, it's not as if your immunity kicks in right away. It takes time after your exposure for your adaptive immune arm to build up and then come down. Likewise, with your immune, when you get vaccinated, it takes some time for your immunity to build up and those cells to be present and for you to make your memory cells so that when you get, if by some unlucky chance you get infected, you can generate an immune response against now the real bug, right? So when you say 80% or 60% or whichever those percentages that you mean, that is protection bad outcomes. Nearly all of them have 100% protections against death and severe disease, but against infection, it's still fairly, we can't expect a great deal. Okay, so that is your individual protection. As you see, it's not 100%. So you can still get infected. You could even get some kind of disease if you have the vaccine. Once you do your phase 3 trials and you have an idea of what the efficacy is, then you have the phase 4, which is the post-licensing safety, which is when you have already probably started rolling out the vaccine. And that's when, for instance, with AstraZeneca, people discussed about the clotting effects and the low platelet count. With the Pfizer one, they talked about the severe allergic reactions. And people want to see, when you're giving it now to millions of people, at what rate is this diversity of human beings with varied immune responses responding to get the vaccine. So all of these phases are extremely important. You have reporting systems, and if anybody in your family has taken a vaccine, you know that that reporting system exists where you can actually send in what your adverse effects are there. And it appears on the website. When I looked, I think on April 12th or 13th, there were about 48 events listed, because I wanted to see what the Indian data was. So I don't know how good the reporting system is, if it is all self-reporting, but that was the list of events that were listed on that particular website. But every country will have some sort of reporting system where adverse events of all sorts can be reported. Serious adverse events. We're not talking about mild chills or fever or, feeling malaise for a few days and things of that nature. I'll tell you again a little story about someone whom I actually some time ago didn't know much about, even though we have Hopkins Institute in Bombay. Hopkins was a doctor who trained, at that time he's a French Ukrainian, he trained in Russia. And at that time he was a Russian. And he was not well accepted, so he decided, I think he could not practice because he was a Jew, and he therefore went to Paris. And then when he was in Paris, and you can read about it again, there are these 2 articles, and it's kind of fun actually to hear about him. And he went and joined the Pasteur Institute, which is again a very major center where research is done in France. One of the major problems in the world then was cholera. So he actually developed an attenuated vaccine under cholera and did a phase 1 trial on himself and a few of his Russian friends who he was able to convince. And they did not have any adverse reactions, and he wanted to vaccinate larger group of people. And, there was vaccine hesitancy. There was like, really, you did it for a small number of people who and you're saying it's all fine. And he was actually advised to go to India, because India had a lot of public health issues with cholera and it was spreading everywhere, and we had continuous epidemics, and that might be a good place for him to see whether his vaccine worked, and then, be a platform from which he could get that vaccine sent to other places in the world, right? That would be a really good thing if many more people are protected. So he did large trials in Kolkata. He vaccinated himself in front of these people. Again, the power of showing that you are taking the vaccine, so it's perfectly fine, and vaccinated a large number of people right around him. He himself would deliver the vaccine, and he did very controlled studies where he would vaccinate some number of people in one family and yet not others. And so he could get really good data. So this is a clinical trial. Sort of clinical trial people even now do, right? Where you recruit people with informed consent and things of that nature, but you recruit people into trials and then do that data. And what he saw with the cholera vaccine is it reduced infections, mortality of those who got infected, which is very, very, very different from what we are seeing in COVID-19 vaccines. That is, you can get infected, but really your mortality, you have very good protection against severe disease, and mortality would be the most severe outcome of any disease. He also developed a vaccine against plague in Bombay. The trials were done in Baikula prison, which is right around the corner here. And again, he saw that there was 50 to 80% reduction in mortality. And I'll tell you here that the efficacy boundary which was set by WHO for any COVID-19 vaccine is that you should have 50% efficacy. And efficacy is described as, some cases it would be hospitalization, other cases would be severe disease, other cases would be mild disease, that any one of the symptoms, if you just got a cough or just got fever or just got diarrhea, any one of the symptoms if you get, then you would be considered as someone who is not protected, right? So it really depends. Each vaccine company has done it slightly differently, but that was the efficacy threshold. And in this point, let me also tell you that there's a great deal of variation. Like Sinovac in Chile, after 2 doses, and in Brazil, shows barely above 50% efficacy. The same vaccine in Turkey seems to show something like some 80% efficacy. So this is interesting that there can be these variations, and we can discuss this later on. And vaccines fail. In 1962, which at that time, inactivated vaccines were a very, very common way of dealing with things, the measles inactivated virus just failed as a vaccine. It didn't work. It gave you zero protection. So this is why looking at efficacy and then effectiveness in large groups of population, and I give the example of post-licensure or post-emergency use licensure, what happened in South America versus, Europe and Turkey, very different outcomes. So there are many, many things to think about in this regard. What is an ideal SARS-CoV-2 vaccine? It should be safe for all age groups. Most of the trials are done from 18 to 65 or 70. They haven't done trials for the younger people. And in fact, if we want schools to reopen, we should probably have some strategy for vaccinating younger people, right? And those trials are ongoing. I know of some trials which are ongoing in that regard, and we will probably get some data soon. It has to work equally well in all age groups and all kinds of groups. What if you're a cancer patient? What you have kidney problems? What you have asthma? Is it still going to work as well for you, right? And so you need efficacy in all ages and all kinds of patient groups. People, it would be great if they did not shed the virus, or if they, when they got vaccinated, if they got infected, or they get infected, they don't shed the virus. That data is known for the Pfizer vaccine, that the amount, even if they get infected, the amount of virus they shed is very, very low. And of course, they have 100% protection, at least it appears they're close to 100% protection against severe disease. It would be great if it needed only one dose, right? Instead of having to go back for a second dose. If you have no cold chain or syringes, it would be fantastic. No cold chain. The mRNA vaccines are held, Moderna is -20, Pfizer is -80. This is extremely difficult for a country of India to roll those kinds of vaccine out in rural parts or even in cities. Where are we going to get that kind of refrigeration? The Sputnik 5 is a lyophilized dry powder vaccine. So you can reconstitute just when you want, and then it will be at 4 degrees, right? So that's much, much more useful in countries like ours, and could really help if it can be manufactured easily. So this would be an ideal vaccine against SARS-CoV-2, or for that matter, anything that you want to make a vaccine against. If these things are met, it would be a much more effective vaccine, which would be, it would be possible to vaccinate people. So let's come back to safety. Is a vaccine safe? Some examples: the respiratory syncytial virus as well as the dengue virus. What ends up happening is the vaccine is presented in such a way such that when you get infected with the disease, your cells actually take up much more of the bug. And then you end up having a vaccine-induced much worse outcome. Now, that is something definitely not happening with any of the COVID-19 vaccines, thankfully, but that's something you look out for. Sometimes you have unintended consequences. In Australia, they were making a vaccine, which is between Queensland University and CSL, where there was a small portion of HIV present in the vector, which is not the portion in which you get vaccinated, of the COVID-19, but in the piece of backbone which is on the side. And people developed immune reactions to the little piece which was coming from the backbone. Now that was a problem, because if you did a HIV test on them, these people would test positive, right? So you can't take that forward, because you can't create a problem saying, people who are not HIV positive, you are HIV positive, because you're now making antibodies against HIV or some fraction of HIV. Side effects, I've already described them at length. Adverse effects could be short-term, they could be late onsets, they could be rare, and I will discuss the AstraZeneca and Covishield ones shortly. Whenever we say that, 6 out of 1 million people you had severe allergic reactions, when you're looking, you need to know what the background rate of such things is. If someone is getting, if 1 in 1 million people is anyway going to get a severe reaction normally, then if you're getting 6, how much of that accrues to the vaccine and how much of it accrues to your background rate? These are kinds of information that we need as public health scientists. And in fact, your control arm may give you some of that, okay? what happens in different age groups, in immunocompromised people. The mRNA vaccines have new technologies and new vehicles for delivery, newer adjuvants. These responses towards them could vary dependent on age. The clotting problems that you see with AstraZeneca seem to be with younger people. Typically, younger women seem to be more susceptible. So all of those are pieces of information that you need, and that's when you can decide that the vaccine is really, really safe. Okay, let's come front and center looking at the AstraZeneca data, right? About, you know that you can have this clotting problem. You also know that you can have very low platelets, and it seems to come much more for younger people than older people who have less of a problem. In fact, Britain didn't spot it because their vaccination was starting from the oldest people working backwards. So what you need is a risk assessment. Are you going to be in a situation where you can take the vaccine, and what your own personal risk is? So let's look at this. If you have low exposure, potential for serious harm from the vaccine, you might have one person having that in these many individuals. ICU admissions much lower in younger adults. Let's start looking at 50 to 59, which is probably, I'm guessing your parents are in the age of anywhere between 40 to 60 years of age. This is your chance of clotting disorder, and this is your chance of getting admitted in the ICU. This is based on UK data. So there might be some variation in India where you may not have as severe a disease, but nonetheless, this is the ratio. This is in the low exposure scenario. Let's look at medium exposure. And what's happening in India right now is not even medium. It's probably some people it's high exposure. But nonetheless, let's look at medium exposure. Then when you have medium exposure, this is your risk. Even at the younger age group, the ICU admissions are much greater. And then you have to ask yourself, is your benefit going to outweigh the low risk that you're seeing with getting specific blood clots, likely due to vaccine? We're not 100% yet sure if it is due to the vaccine or is it due to the backbone, because there were some 1 or 2 cases which came for the Johnson & Johnson single shot vaccine as well. So this is the way you take that risk assessment. And I would say that for India, it is advisable for people to get the vaccine, especially now when you have such spread taking place. So here's another way of looking at risk, right? Serious side effect and harm at a 25-year-old, there are 11 cases max per million. It's, this is slightly different way they're looking at that risk number by giving you that data. At 54-year-old, it's 55 years old, it's 4. In road accidents, it's 38 in a million. In India, it's going to be much more. The people who can die on roads, much, much more, I think. Dying due to accident or injury and dying due to coronavirus. So on a balance, it might still be very, very useful to get the vaccine when your turn comes, no matter your age. And of course, we don't have to go for the AstraZeneca vaccine, but you can go for the other vaccines which are going to be available in India, like Covaxin. So I just want you to think about, when you do risk assessment, and safety is so important, there are multiple ways to assess risk. And this sort of table gives you some way to start quantifying that risk and say, how scared should we be? Should we go for this vaccine or should we just ignore it? Okay, so those are important things to consider. Does a vaccine work? I think we've gone through it with, fairly thoroughly, but I'll still go through a couple of issues here. How well does it protect in regular use? Effectiveness versus herd immunity. Here I'll highlight something which was an aggregation of studies which came from the use of the AstraZeneca vaccine. And what was seen was the following, right? These were they looked at all the data that they had collected. So it was not something that was designed and planned. And what they were asking was, what is the level of protection after you get one shot? And does it matter when you get your second shot? So early on, when the first trial started coming out, they said when you have one full dose followed by second full dose, about 4 weeks apart, got 62% protection. When you got a half dose and a full dose, then you got, close to 80% protection. Now, what was approved by the regulator for the clinical trial was a full dose versus a full dose, right? So when you're doing a full dose versus a full dose, which is what is approved, and that's what we're getting in India, you can't start giving a half dose and full dose based on little bit of data where shortage of vaccine, they did that in the trial. Is that if you waited longer periods of time, and in fact WHO suggests 12 weeks or longer as the gap between the first dose and the second dose of AstraZeneca, or what in India would be Covishield, then you seem to get much better protection than when you take it earlier. At least we can say from looking at the data that there is no harm in waiting longer, give you better protection, compared to if you took your doses at a 4-week time point. And it was based on that information that the government also said instead of taking spot at 4 weeks, you could go up to 6 to 8 weeks to take your second dose. But those decisions, again, will be made based on your local risk. So if you're living in a place where you have a lot of risk, the infection, your local ability to shield yourself is low, or you have to go out and work, you may be better off getting your second shot sooner than just making do with the first shot, which might give you about 60 to 70% protection, about 60% to 70% protection, right? There is, again, a huge variation from individual to individual. So those are the issues to think about. How long does the protection last? We clearly see that in some people, not with the vaccine, but with the natural infection, the seropositiveness goes away in 7 to 8 months. In India, in 6 months, a fourth of the people in the study done by IGIB shows that the seropositivity has gone away. So waning immunity is an issue. Is it going to work the same with the vaccine? We don't know. If that's the case, some of the modelers who are looking at this data and looking at this surge say there are only 2 ways you can explain this. One is we never reached herd immunity. 2, there is waning immunity. And the 3 is we have these variants which are much more infectious, right? So those are the issues to think about. How did we get COVID-19 vaccines so quickly? Several technologies which are well established. The SARS and MERS were similar viruses and they have come around. So we knew which protein to target. We knew the spike was the one to target because spike was what was used to enter. The preclinical and clinical efforts ran concurrently. Usually they run very slowly. You do preclinical, you get some data, then you wait around for some money, and then you do some part of the clinical, then you do some more part of the clinical. Your phase 1 itself takes a year and a half because you don't get enough money, you don't get enough volunteers. Part of it, regulatory agencies worked with the agencies. Production capacities were ramped up before efficacy was known. Serum Institute of India in India made the vaccines, took a bet on the AstraZeneca that it would work, and made the vaccines before we even knew whether it worked or not, right? And it turned out to be a really good bet, and we're still running short, right? People were willing to volunteer. Hats off to all the people who volunteered for back-to-back trials to get this. And for some vaccine candidates, all steps were followed and data and interim data were available for independent review, which makes us scientists very happy. Okay, what are the coronavirus vaccines in India? We have a full spectrum, and I already told you about Zydus Cadila, which is going to, I'm sorry, I think I'm running out of time. Zydus Cadila, which is a DNA vaccine, which is in phase 3 trials, but we have a full setup, which some of them are indigenous, some of them are tie-ups. We know Sputnik 5 has been approved, which is a very clever design with one kind of viral vector for the first dose and a different kind of viral vector for the second dose, allowing you to boost your immune reaction just against the spike protein and therefore potentially giving you much better efficacy. So what happens with Covishield? You have a viral vector with this adenovirus, which has within it the DNA for making the spike protein. It enters the cell. makes plenty of it, makes the DNA, makes the lots of mRNA, and then presents the protein on this surface. After that, an antigen presenting cell comes, engulfs those proteins which are being shed from this cell, and then comes in, it presents it, and then stimulates the T helper cell, starting both your B cell and T cell antibody as well as cellular immunity involved. What happens with Covaxin? And by the way, it's the same for Covishield and Sputnik 5, which will enter into our market at some point. What happens with Covaxin is you have virus, which you have to grow the virus. So it has to be done in a safe manner, right? That's very, very important. So you grow the virus, you inactivate the entire virus. Now, this entire virus is eaten up by the antigen presenting cell. Bits of it are presented. Now it will be a diverse set of proteins which are presented, right? This is not just going to be the spike, because that's what the adenovirus does, just presents the spike of the coronavirus. And the downstream, it's the same. You then use the B cell with respect to with the helper T cells to make antibodies. These antibodies will coat the virus when you get an infection, and they can be neutralizing or they can aid neutralizing antibodies, but essentially you. And you also have the T helper cell arm, which will go and recognize the cells which have gotten infected and then go and kill those cells. Now, one of the biggest problems which we are going to face, which is natural, and in fact, it's only because COVID-19 is not a special bug in any way. All standard things apply to it, okay? Including the fact that you have transmission before symptoms. This is known for polio. It is not as if it's something new. This has been seen by people who are infectious disease experts many, many times. So we're not new in that regard. In fact, it's a repair. It repairs itself and doesn't accrue a lot of changes. But right now, so many millions of people are infected that, of course, you have in each human being that you have replication taking place, you can have small changes in the virus because there are just so many people who are infected. And some of them appear to be able to bind to the ACE2 receptor much, much better. Shown. Okay, I guess we won't go back so much. Some of them are able to replicate more, and some of them are able to escape some of these neutralizing antibodies, and more recently are able to escape this T cell based immunity. And the T cell based immunity seems to have been critical in SARS, right? When SARS, the T cell based immunity has lasted for nearly 2 decades, which is really, really remarkable, the memory T cells, which can kill infected cells. So that is, of course, a cause for concern. Nonetheless, it appears that most of the vaccines still will provide some degree of protection, because it is not as if when you think about variants in the spike protein, and there are 2 which are of interest, although there are many other many other variants. This spike protein has many epitopes, so antibody will be made to lots of different parts, not just those 2 residues. So despite vaccine escape or immune escape, and there are breakthrough infections, for instance, you have a paper coming out from Israel showing that, a good fraction of the population has been immunized, but you still have some breakthrough infections, and most of those breakthrough infections are South Africa virus, and a little few of the not the South Africa virus, but the virus which was first identified, a variant which was first identified in South Africa, and a variant which was identified in the UK for a small extent. So that tells you that that breakthrough will occur, but nonetheless, majority of the population is protected, and the breakthrough that has occurred, those people did not have terrible outcomes. So they did get sick, they did go into hospital, but they still had some degree of protection. So despite this, I think there will be updates to vaccines that will come, but one should not turn one's backs on vaccines saying, I will wait for a better vaccine, because even the current vaccines will give you some protection. Okay, from now on, it's easy listening. The issues, I've sort of sensitized you to a lot of issues if you hadn't thought about it with respect to the vaccines, or you might have bits and pieces of it coming through news sources. There are many, many different COVID-19 vaccine initiatives. You know of the Operation Warp Speed in the US, but really I want to highlight something which is called the COVAX facility. You know that India plans to donate vaccines to the COVAX facility, which actually ensures that people across the world can be vaccinated. And that is going to be extremely important, especially as you're seeing all of these variants. So you do need to make sure people are protected. Otherwise, you don't know where the variant will pop up, and you can't control people's movement all the time. And, something is going to come in and then upend societies all over again. And just based on humanity and intelligent self-interest, this is something we should do. And really the idea of the COVAX is nobody wins until everybody wins. So let us try and protect as much of the human population as possible by, building up our capacity, by donating to specific groups of people. It also allows, remember, vaccines are made by companies, which are corporates, and people want to be able to negotiate good prices, right? If you remember, the Serum Institute person said that we will sell one vaccine in the open market for 1,000 rupees, but we will provide it to the government for 250 rupees, and the real cost is 200 rupees. So you can just see what the markup is, even here, right? So the COVAX facility allows countries and groups of people who are not, and India is going to get a lot of doses from them, millions of doses from the COVAX facility. So we are also beneficiaries of it. I'm not asking you to see anything here. This was vaccines which were approved in at least one country. I pointed out that, I was going to point out Israel's story on the mRNA vaccine for both Pfizer and Moderna vaccine and Covishield. And now I can't even get it on a single slide. So here's one, and the AstraZeneca Covishield. Lots of countries use it. Here's Sputnik 5. And if you look at Covaxin, which is right here, several countries have approved its use as well. So compared to February, when there was only one country, now that we have the efficacy data, and these countries will have their own internal processes, although I told you that Brazil said no, nonetheless, it is something that has been approved. Our vaccines in phase 3, the Zydus Carilla, which is an Indian company with the DNA vaccine, that would be the first time ever. Novavax, which has preliminary data suggesting that has 89% efficacy, and several of them, the efficacy, including the Johnson & Johnson, seems to drop against the variant that is present in South Africa. We don't yet know how well the vaccines work against every variant and new ones which are coming up. But, as I said, it will still provide some degree of protection, and it's not something that one should turn our back on. Vaccines in development. You can see over 200 vaccines. 16 are in phase 3 trial. These are all the various technologies, and you can look at it every week. WHO updates it. And vaccines, what are the routes of administration? Is it single dose? Johnson & Johnson is, by the way, a single dose, and it's also viral vector vaccine. It's a single dose. That's very convenient, as I said. So 1 dose, 12% of the vaccine. 2 doses seems to be the most common, and 3 doses seems to be less common. This is the way they're going to get in. There's, 2% of them are just oral route. Most of them are injectable, right? And for some, there is no data. So you see that there's so much complexity that goes into taking a vaccine, which is an idea in someone's head, all the way to a product that we can deliver to people in our country or in any country. What is the status of WHO vaccine approvals? In January, there was only one which had been approved, but now there are several which are approved, and here you can see that, again, that's all available on their website, and you can look at it. Serum Institute got approved mid-February, and you will see there are different AstraZeneca approvals, actually. Here's AstraZeneca made by EU nodes, AstraZeneca made by SK Bio. But anyway, Serum Institute is approved. The Gamalaya, as you see, several meetings are held, rolling submission of data, and the approval inspections will happen in both April, May, and June. And that's when it happens. Bharat Biotech is still in the midst of, they have not yet submitted all the information. There's still information that needs to go. So that's where we are with the 3 vaccines, which two which are now there in India, although most of it is actually Covishield, which is done by Serum Institute, and one which will hopefully come in not too distant a future, which is the Gamalaya vaccine from Sputnik 5. Clever design. There are many vaccines in the pipeline, as I showed you. And the reason is the need in high. 4 or 5 companies will not be able to supply, especially in a short time. And I already talked about temperature stability, dosage, distribution. Some of them might be cheaper. The Johnson & Johnson is single shot, which is very good. That means it's half the price if you want to get it in the private market. Long-term protection still needs to be addressed. Updates may be needed currently to expect to work against UK, but less well against South African variants. I've already discussed vaccine escape. Please note, clinical trials are getting harder for newer entrants because you now have a vaccine that you can take for many places. And you need an active pandemic or active epidemic locally going on so that you can get people who have a chance of getting infected. So those are all real issues for newer vaccines getting approval. I don't think there'll be a huge problem for Zydus Cadila, which is our own homegrown product, although they may not have a huge production capacity because Covaxin we don't have a huge production capacity. And as many of you may have heard, some of the key components of filters and tubes have been sequestered and kept for the United States preventing its export, therefore hampering our own efforts to make vaccines for both our country as well as for other countries in the world through the COVAX facilities. So some real problems over there. I mean, this is something which all of us should be aware. This word, the vaccine pre-orders, is a percentage of population. This is likely, it doesn't matter if it's old or new data. Just look at how much people took a bet. In fact, I remember listening to Fauci in one of the meetings which was held in India. Many people from the world came and he said, we've just decided to invest in this. We've put money into it. We don't know which vaccine is going to be successful and we have just pre-ordered it. For instance, that the EU funded AstraZeneca but did not reserve doses for itself, whereas whatever money that the US gave, they reserved doses for themselves. So the outcome is that EU doesn't have enough doses of AstraZeneca. Of course, now they don't want to use it because they're worrying about the blood clots, even though, as you saw, how low the probability of that blood clots was, and it's still, on an average, provides a lot of benefit, especially in a country like ours where a raging pandemic. Right? So as a fraction, some of these countries have ordered 200 or 300% of what their population needs, where there are others where there's absolutely nothing pre-ordered, right? There just is nothing because they have no resources. So this is something which brings us bang in front of seeing where society, science, and politics intersect, and economic power. And therefore, public health is affected by all of these issues, and something which young people might want to think about and maybe even work in areas associated with this. And here is India. We have pre-ordered some vaccines, but it doesn't even cover 100% of the population, right? So this is the low and middle income countries, and these are high income countries. And then, of course, there are far poorer countries which have not been able to pre-order anything, and they depend completely on COVAX. The speed of vaccinations, again, here is the color code. You can see that light, no data. The lighter the color, less the penetration of vaccination. So here are the top countries. Israel, 60% vaccinated. Chile, 41% vaccinated, but yet they are facing lockdown again. There's raging pandemic there, and part of it is because they took the Sinovac. They also have Pfizer BioNTech, and they also opened up, is one of the things they're saying, where people drop their guard. And we are in a situation, at least that country is in a situation, where they're looking at lockdown again, and the Sinovac vaccine itself doesn't have very high efficacy, and certainly after the first shot doesn't seem to do much at all, 3% efficacy, and that data is actually in Spanish. I translated bits and pieces of it with the help of my daughter, who knows a little bit of Spanish, and Google Translate. Okay, so these are the countries. You can say the United States had vaccinated 38% and fully vaccinated 24%. I mean, look at 1%, right? So we are there. We are not high, but we are non-zero. Vaccines can have an effect countrywide on infections. This is from early end of Jan, where in Israel, when they were started the vaccination, greater than 60 years, 90% vaccinated with one dose. There was a 41% drop in infections. Less than 60 years, 30% were vaccinated, and there was a 12% drop in infections and 5% drop in hospitalizations. And again, this is the Pfizer BioNTech, which does in fact seems to prevent infections as well, because the amount of shedding that happens is much lower. That same data shown as graphs, you see there is a vaccine effect that you see in terms of cases. This is when the vaccine began to roll out, December 18th. They actually started a lockdown, and sometime in mid-January, the second dose started being given, right? So they started a lockdown around then for a short period of time because their cases were increasing, but they've had a real decrease in both the number of people who are testing positive and number of hospital admissions. In fact, in mid-March, they have opened all their bars and dance bars and things of that nature. This is their false first wave, their second wave, or maybe this is not to be called a wave at all. I wouldn't know. I'm not 100% sure if that would be called a wave. But right here, they have gone back largely to a normal society. And sometime in Jan, they started vaccinating, and as more and more people in their country started getting vaccinated, they were able to open up. The number of deaths really came down. So deaths can decrease with vaccination, even with COVID. I want to end by saying that vaccines are not a magic bullet. Vaccines so far protect against disease and not much against infection, at least not the ones that we know of, like AstraZeneca. We might have a different role if we see something. If we look at, the Pfizer, there might be some, because they don't shed as much. So there might be effects on infection just because of break the chain. So we need to continue as a community to mask up. Even talking is a pretty bad thing and sheds virus. So we have to mask up. We have to use electronic means of communication, and we have to be in places which are well ventilated as far as possible. And we have to aim to get with vaccines beyond priority group. We will have, now that we know about waning immunity, people who maybe got the infection nearly a year ago are probably good peak candidates to start thinking of getting them revaccinated. So that advisory, after looking at all of that data, especially in India, it's important to put that in play. There are people who don't take the plan to take the vaccine. I think there are fewer and fewer as we go along now, especially with this surge that we are seeing recently. Some people say COVID-19 is not a dangerous disease. I will always say that, yes, population level, young people do well. On an average, it's older people, and even there, most people will recover. But remember long COVID. Remember that 6 months post-recovery, you still have 50% have lung issues and lung damage. So you might want to keep that in mind and say, it might not be as dangerous as killing you at every point, although no person knows what the individual risk is. And we all know young people who have passed away. And we have known old people who have recovered and done fine. Some people worry about side effects and safety. I think it would be fair to say that Covaxin and Covishield seem largely safe and acceptable side effects. Vaccines do not cause the disease. Covishield simply absolutely cannot cause the disease because it's just a fraction, a small fragment of the virus. And Covaxin is an inactivator. So if they did their job right, it in no way should be able to cross the disease. Some people worry that, and we will certainly have a nucleic acid vaccine, I hope, that will change your DNA. No, it cannot. We eat vegetables and fruits every day. We're not changing our DNA. And they're all food that we eat has DNA in it. Vaccines are for children. That's not true. Vaccines are for all ages and stages of life, and we need to change our thinking. Some people worry about the cost, but really, I think the government is providing it free of cost for most people. In fact, I think the the government is a huge deliverer of vaccines and has always been in our country. I'll end with this last slide. There are some things which are personal responsibilities which we all need to buy into, and some are shared responsibilities of the community. The personal responsibility is that if you have even one of the symptoms, please look at WHO, everything from conjunctivitis to diarrhea, right? It is a good idea to isolate, because nowadays what's happening is one person gets infected, the variants that seem to be circulating perhaps are able to infect others a little bit faster or bind tighter. Entire families are testing positive, which was not the case, maybe 7 or 8 months ago. So very wise to take precautions. Very, very wise if you're anywhere stepping outside home to be properly masked. You can even consider double masking. I know it's miserable. When I go out, I feel the same. But unfortunately, that's what we need to do this day and age. And please don't touch your T-zone. No eyes, no nose, no mouth. Handle your mask only through wherever you tie it, not the other places. Wash them or dispose of them safely. And thank you for your attention. I think I've done what I intended to. But I hope that you gained something from it.
Thank you, ma'am, for the wonderful talk. I think we'll take questions now. Bivas from our team, he'll be relaying the questions. He'll be calling out the people with questions, and then we can take them. Another thing, there will be a feedback form in the chat. Please fill that up. It'll give you an option to add yourself to our mailing list so that you can be updated for the future events as well. Thank you. Bivas, please go ahead.
Hello, ma'am. Thank you. That's a great talk and great informative talk, I think. And there are a couple of questions, many questions that are popped out in the Google Meet. So I will be calling out the name of the participants. If you can unmute yourself and ask question to ma'am. So there are a couple of questions from Tejas Thombre. Can you unmute yourself, please, Tejas? Okay, no problem. I will ask his question. He asks, adaptive immune response will take weeks for controlling viral load. So can we develop some therapy that will enhance adaptive immune response so viral load can be maintained?
As far as I know, there is nothing which can tune your adaptive response in that manner. However, once your adaptive immune response kicks in, and if it works as advertised, and for instance, you're not suffering from COVID, from cytokine storm, your disease outcome will be very good. Now, what happens when you get in vaccination is you have that 2-3 week period at least before you have the full spectrum of protection, simply because that is the time the adaptive immune response takes to build the cells, to have the right response. Because as you can see, it's a stepwise process. One cell takes it up, then it has to present it to another cell. Enough number of those cells have to present it so that then you get your T helper cells coming in, and then you stimulate it. Because it's a stepwise process, it takes a little time for that to build up. As far as I know, there is no process or to improve it in any way. And you shouldn't worry as much about viral load as disease. It's true that viral load can correlate with disease, but it's not a 1-to-1, 100% correlation for each person. So as long as you are not in a diseased state for which there's medication and there are other ways to treat it, dexamethasone was the early success and still seems to work quite well. In certain cases, you can use remdesivir in very, very limited number of cases. But you have to manage it. As long as you're given oxygen, you're in a prone position, all of that seems to help to have a better outcome, better clinical outcome.
I think that has answered Tejas' question. There's a question from Swapnil. Can you unmute yourself, Swapnil?
Can I say one thing? Tejas also says, wearing a 3-layer mask, cotton mask, surgical mask alone is not effective. Other precautions are also necessary. I agree. But in a country like ours, maintaining physical distance is very difficult. Right? So if you mask and physically distance, you will mitigate risk because, viral particles will not go out as much. What is very, very critical, that's why I suggested you could consider double masking. Each mask, so if you have a 3-layer cotton mask, which fits well, covers your nose, maybe it even has a clip and covers your mouth and does other things, and then you put a second mask, each of those masks might cut viral entry into your mouth and zone by 70%. So you can, 70%, that adds up. I will give one suggestion which comes from Arnab Bhattacharya's work that he did which he did in TIFR, and you can catch his Chai and Why, where he talks about mask. An N95 mask is a single-use mask, and you have to sterilize it and decontaminate it before you can use it again. You can't hand wash it, right? And a poorly fitting N95 or an N95 with a valve, no, please don't use it. It doesn't protect somebody else. So it's much better to use 2 masks, one which is your cotton mask and maybe a surgical mask on top, or your cotton 3-layer mask and a second mask where if you're outside will do a much better job. The fit is key, and that's what you need to do. And of course, the other things matter, but that's why I showed the Swiss cheese model, that multiple things need to be put in place. Sorry, go ahead, whoever was.
That was pretty interesting. Last slide was pretty interesting, and the way you put up the slide, it's very interesting. Yeah, Swapnil, you can ask your question.
Yeah, can you confirm I'm audible?
Yeah, you're audible, Swapnil. Go ahead.
Yeah. Thank you, Sandhya ma'am. It was a really great talk. I had many questions, but you had answered in subsequent slides. So primarily, there are 2 questions now. Recent studies show that COVID-19 is also airborne transmitted. So do vaccines, as they are being circulated as of now, can they be effective for an airborne disease? Because I don't remember any epidemic or pandemic which was...
Measles. Measles is airborne, and measles vaccine is very effective. That's one example. But you should recognize that COVID-19 being borne by air has been known, I would say, at least since last July or August, because you can have droplets of different sizes, and some are extremely small. Okay? And when they're extremely small, they will not fall down and settle. They will hang around in the air. So the next person who comes in who's not properly masked will get it into their respiratory system. And now, if you have variants of the original coronavirus, which can bind tighter, then you may need fewer viral particles to bind to your nasal passages and cause that infection, right? Which is why masking is so critical at this stage in the pandemic. But per se, just because it is borne by air or airborne, there is absolutely no worry. The vaccine will work against it. If you have elderly people in your family, please encourage them to get it.
Sure. Thank you, ma'am. Actually, all of my elderly relatives are vaccinated, at least the first shot.
Fantastic. And then they should shield. Then they should mask and shield and minimize mixing, right? That's all we can do. And hope for the best.
Yes, exactly. And the second one was, you might find this a silly question, but do remdesivir and vaccine, do they complement each other?
No, they're completely different, because remdesivir, so drugs and vaccines are completely different things, right? The drugs treat the symptoms, but the vaccine sort of is something like a prophylactic, right? Sort of sets you up so that you can fight off the disease. Way better than anything that we say, ye khaoge to tumhara acha immune reaction hoga. I think adaptive immunity can be tuned through, or unfortunately, of course, if you get the disease. But those are the only 2 ways. They're completely independent.
Okay. And ma'am, last question. So just for taking some findings from this COVID experience. So for future, can we first develop a vaccine for animals with the COVID zoonotic disease? Then can we
We, you know,
vaccinate animals just like we vaccinate
what will you act?
pets?
So let me give you an example. Let's just take the coronavirus family, right? SARS-CoV-2 come from which animal? Maybe bats. There might be some contribution from pangolins. SARS-CoV from civet cats. MERS from camels. There are many reservoirs. It's so important to recognize that we are one species among many species. All of these have come from vertebrates. There's absolutely no reason to think that new source, right? Like bird flu. It might well be those bats, for instance, don't fall sick with coronaviruses. The cold causing coronaviruses, we only get a cold, but this version is doing different things. In fact, it is the ACE2 receptors present on so many. So I think it's very hard to do that. But I would say what we as individuals in a society, especially a developing country which has aspirations to have better economic outcomes, which is very, very important, constantly be thinking and innovating, and in which we don't harm the environment, that we protect our ecosystem while taking care of humankind and our needs and our desires. I would call it that each person, do we really need that second car and that fourth house? Right? Because each footprint that we increase is a forest that we have maybe cut, or fossil fuel that we are using to pollute the atmosphere, which is now making what would be reservoirs which are contained in certain places now come out because you have much more human-animal conflict. Right? These are issues that we as societies need to think about and say what is the amount of risk we are willing to accept. Not every disease which crosses over is going to be bad. There is one which came from the forest, which I might mispronounce it, is Kyonosur Virus. Nityanand Rao wrote a very nice article in The Wire about it. You can go and read it. They found out it came from the forests in and around Karnataka, but then it died down. It didn't spread in our population. Right? So you can have many outcomes. In this particular case, we had a bad outcome. So I think that really it is human-animal conflict and not thinking about the world in one ecological unit where we are all interdependent. Who knows how many diseases we as humans are giving to animals?
Sure. Thank you, ma'am.
Yeah.
There's one question from Sunita Garg. Sunita, can you please unmute yourself and ask your question?
Yeah, can I ask? Am I audible?
Yes, you're audible.
Yeah, I just wanted to ask, we go, ma'am said that we shouldn't remove our masks when we're in public, right? But if we go for a jog, or if we go for a walk and running, so we have to remove the mask at that time. So what should we do at that time?
So please make sure you have enough physical distance. So obviously if you go for a jog and if your oxygen supply becomes very, very low because you're running very hard, that would be a problem. If you can maintain good physical distance, I would do that. Or I would say, in this situation, wouldn't a walk be better, or cycling? So you don't put yourself at risk, because clearly a large number of people are infected. Or indoor exercise where you are in your safe space. Those are all things to consider. So you have to think about your own environment and see how can I mitigate my personal risk. What are the actions that I can do which will mitigate my risk as far as possible? Because each of us lives with a lot of people. In Bombay, the apartments are small. So each person who brings a certain amount of risk into the family, that risk in this situation is going to be, if you get infected, could very easily infect other people. So I would take that on. initially there were guidelines which comes from the WHO which said that if you wear a mask and run, it's not such a bad thing, but be careful because you could run out of oxygen. And I've certainly seen people on my campus go for a run with mask on. If you don't want to, then make sure you're vastly physically distant from anyone else that you're going to run with. But I would also encourage you to consider alternate forms of exercise which are not maybe so vigorous or can be done indoor, which might help mitigate your personal risk. That would be my suggestion, not prescription.
Thank you, ma'am. There are a couple of questions from Akash Chandlia. Can you please unmute yourself?
Ma'am, you also talked about waning immunity.
Yes.
Could you explain, like once a person gets COVID, and how does it and work, and how the antibodies, and I mean, what do you actually technically or medically imply by the word waning immunity?
It's very complex, and I don't think we understand it. Okay, so the idea of waning immunity, so let us say where we were with the pandemic or epidemic in India in January. Cases were going down, things were looking good, and we were opening up, right? So then the modelers, then we suddenly got this surge, and this surge may have started in parts of Maharashtra, in smaller cities of Maharashtra, but now so many urban centers are having this surge, right? The virus doesn't respect, ye Maharashtra and this place is some other place. No, as long as people move, the virus is going to move with them. So now when people run models, they are not able to fit the data or explain the data unless they consider a couple of things. Greater a variant which is able to infect more, as well as people whose immunity has waned. What does that mean? That actually means that those people can get infected again, right? That means your front line, you may still have better outcomes, right? Because you've had that infection before, so you may still, your memory cells might be still good enough to wake up, make enough antibody, and make sure that your disease outcome is not bad. But you will still test positive on an RT-PCR test. And you may also not have any antibodies circulating in your blood. So you're depending on your memory cells to kick in and do the job, which will take some time. It will take a few days to expand and make enough antibody. By the time your infection has happened.
So there's a lot about eating a lot of protein-rich diet will help your immune system, because all the immunoglobulins are made of protein, antibodies are made of protein, and there is a lot of thing going on in the environment and the market. People say protein. Can you just throw some light on this too?
A normal healthy diet with well-nourished food, regular food that most of us eat will be fine. Okay, so some people who have severe obesity or have problems with absorbing nutrients need sort of supplements. But for most people, normal food that you take is good enough as long as you're well nourished. So it should not be skewed towards anything. Just a normal well-nourished diet will give you, will keep you in good shape to fight off any disease, not just COVID-19. Right? So it depends on how severe your infection is, how your body responds, but having a high protein diet has not been shown to provide benefit.
Okay.
Ma'am, can I ask the last question?
Yes.
So, thank you, ma'am. I just wanted to ask that actually my mom got vaccinated, like just the first dose. And my aunt got it, like both of them got it together. But my aunt just yesterday, she
tested positive.
Yeah, she tested positive.
Remember what I said about personal protection? That is 70% against infection, or 80% or 60%. Whatever the efficacy is, that efficacy is calculated after 2 doses. With AstraZeneca or the Covishield vaccine, that range is anywhere from 52-53% to 70%, 75% after the first shot. There's a whole range, right? You can say on average there is around 60% after one shot. So if so there are two possibilities. The immunity, it's not been 3 weeks, so the immune system has not made enough antibodies, so they would get more severe disease, or that they can get infected, but because they have the shot, their disease will be much less severe.
Okay.
Testing positive is not a terrible thing. It's a worrisome thing. It means you have to be isolated. It means you have to be careful. That means your immediate environment, people have to support and take care of you, making sure you're behind a closed door and there's no mixing taking place.
Okay.
However, especially if you have both shots of the vaccine, your outcomes for severe disease are really, really mitigated. But your outcomes for infection is not the same. You can get infected. Your personal protection is anywhere in the range of 70 to 80% after the second dose.
Okay. Thank you so much, ma'am.
And there is a question that has came up like many a time. So people are asking, is the vaccine safe for the patient with asthma and blood pressure issues? Like, is there any other side effects the vaccine available in the market?
I think you should look at what the Indian government recommends, and actually they have fairly decent recommendations. I think pregnant women is one of them where you have to be careful whether you get it. If you have blood pressure, please go take the vaccine. In fact, that's a comorbidity. If you have diabetes, go take the vaccine. That's a comorbidity. So if you get the disease and you have if you get COVID and you have diabetes or blood pressure, you're more likely to have a bad outcome. So you do not want to go that route. I think these people should get the vaccine. It is definitely meant for those people. And in fact, if you looked at how the vaccine was rolled out, after the frontline workers, it was older people. And then they said anybody who's above 50 who has comorbidities like diabetes or blood pressure, or if they had, cancer treatment, those are the people who need to get it.
There's a question from Anvesha Mandal. So can you
severe allergies, pregnant women, those people are advised not to get it, or advised to speak to the doctor before a decision is made. Sorry. Yes, go ahead.
Okay. Yeah. There's a question from Anvesha Mandal. Can you please unmute yourself and ask the question?
Yes. Thank you for giving me this opportunity. So my question is, ma'am, you mentioned that some viruses escape the T cell, which are previously being introduced by the virus proteins. So if this is the case, then how it will induce the immunogenicity, and then what is the way out?
So when you think about it will escape T cell response, you're actually thinking in terms of, so there is nothing is 100%, right? So when you have your vaccine response, you will have some memory T cells and you will have some B cells which can make antibodies. They both work in different arms. Not all, they're both very different. They're not exactly the same. For instance, there are residues in the spike protein which seem to be able to escape certain monoclonal antibodies which are used for treatment. Okay, so that means that they are undergoing some sort of immune escape from those monoclonal antibodies. But other antibodies are there. So if you get a vaccine and you will make an antibody against every part of the spike protein that is over there, right, or many parts of it. So not just the neutralizing antibodies. So that is how it mitigates disease. The second thing is it might escape T cells, which is worrisome. That means that you might have a slightly worse outcome than otherwise. But on the other hand, it's not all or none. There are more than one arms of your immune system. And so I would still say that taking the vaccine gives you your best chance. It adds a mask to it's like adding a nice good mask to whatever 2 masks that you're already wearing. Right? So this is the additional layer that you should get. But we don't understand it enough, right? So the L residue, which is being mutated and seen in India as well as in California, there's just a preprint come out earlier in the month. So it's not even gone through peer review. where they show that this residue can undergo immune escape from the T cell immune escape. That's the first report. So let's wait to see how the evidence comes and whether we should worry. I don't think we should worry right now.
Thank you very much, ma'am.
Okay, ma'am. There are a question from Sandhya Kadiru. We will be taking 3-4 questions more. So there's a question from Sandhya Kadiru. Can you please unmute yourself and ask your question? Okay, I'm reading out your question. Ma'am, she asked, my parent is a 82-year-old. She is taking blood thinning aspirin medicine, cholesterol medicine, and hypertension medicine. What precautions should she take before taking the medicine?
Before taking the medicine or before taking the vaccine?
Before taking the vaccine, sorry.
Okay. So definitely should consult the doctor if there is anything to worry about. But I would say that looking at the data, that if what you're thinking about is what about these clotting side effects and the low platelet side effects, older people seem to not have them as much. So I would say go ahead and let them take the vaccine. And it's probably going to turn out to be just fine. It's most probably going to turn out to be just fine because the chances of getting those clotting problems at older ages is very, very low.
Okay, there's a question from Batul P. Can you unmute yourself and ask your question?
Ma'am, good evening. I wanted to know that why is the first dose of the vaccine not effective? Like people are still falling sick, and why 2 doses? And also, if the second dose is the one which is giving us the safety, then should we not take the second dose early? Why wait for 6 weeks?
So, first of all, as I said, after the first dose, you need 2 to 3 weeks, sometimes slightly longer, for your antibodies to be produced and for the adaptive immune response to really get kick-started. And that's when you start seeing some protection. You should recognize when people are getting infected that after the first vaccine, that time may not have elapsed. Second, even if that time has elapsed, we might have a variant which is at a much lower dose able to cause infection. So the efficacy studies were done when different variants were going around, right? So we are just translating that to the current status of the epidemic. That's very difficult to do. Generally, booster doses are, and also those variants studies have been done in different parts of the world. I gave you the example of how Sinovac had different efficacy in Turkey compared to the efficacy it was there in Brazil and Chile. Both of those countries have the variant which was first identified in Brazil circulating. So you may not be as effective against it. In fact, after the first dose, there is essentially no protection, right? 3%. It's nothing really to write home about. So those are caveats. Now, based on what data is there and what we know in general about booster shots, all booster shots, and many people, if you look at infants also, they'll not take only 1 dose of vaccine. No, after at some 3 months, they will go at 9 months, they'll go at 1 year, they'll keep getting vaccine shots and they're getting these booster doses. You have to wait at least for a period of 4 weeks for the booster dose to work as a booster dose. Essentially, what you want is your antibody levels to come down before you give your second shot to do this prime boost again. It's called a prime booster dose that you get. So that is why you want to wait at least 4 weeks. What the data shows with AstraZeneca, and that might be because it's not a heterologous prime boost, that is, it's the same viral vector at both times, that actually what their data suggests that if you wait longer, there is a chance that you will get better protection. So that's why one of the things I said is that whether you wait for longer is going to depend on what your exposure is. Supposing it's a 80-year-old person who never leaves home and they're living with one other individual or two other individuals who are extremely careful and can work from home and are masked all the time. Even when someone delivers something to their house, they do not, they maintain distance, they do electronic payments, and they don't come close to them. They leave the box over there outside and they leave or something like that. Then you would say that no, it's probably better to wait so that they can get the best protection, best efficacy later on, right? That would be the choice. Now, if somebody is someone who has to go out, has to go and mingle with people, has to take Mumbai trains, or epidemic spread right now is extremely worrisome and there are a lot of people infected, you can go a little earlier, right? So that's going to depend on your local risk. And that local risk is something that you do have to accept before deciding when you take your second shot.
I think.
Thank you, ma'am.
Okay.
Yeah. We'll take a last set of questions from Nitesh Kumar. Nitesh Kumar, can you please unmute yourself and ask your question? Okay, I will read out his question. Against which strains of SARS-CoV-2 are these vaccines effective? Like, as we know, virus mutate very fast, and there is not only one strain that is causing COVID-19 disease. There are many. So are these vaccines effective against all of them?
So what we saw, where there is data, we saw that the AstraZeneca vaccine did not appear to work against the variant identified in South Africa. The Johnson & Johnson and the Novavax, which is still in phase 3, not yet complete, their efficacy dropped, but it was still fairly high. It was well above 50%, and I think which was the cutoff set by WHO as an acceptable threshold. But in India, we don't have the variant which is from South Africa. We have different variants. And only time will tell with these specific variants. We are only now sequencing. Now sequencing has caught up steam, and while we may not have the number of sequences that the West has done, but now we have some sense of what the spread of variants is. I think the data will start coming. As of now, I would say that there are going to be multiple versions of the variant which are circulating. We will get updates in the vaccine in time. So the people who get vaccinated later might have, a slightly different variant that they are vaccinated against. But I think the fact that it can protect against severity of disease is something to keep in mind. There are multiple epitopes on that spike protein. You will make antibodies against lots of them. Some of them will react against the newer variants. Just a few amino acid changes is not going to prevent all the antibodies from binding. So I think there is still a very good chance that, in fact, I would say I would be surprised if they did not bind to the variants and do something. Right? Yeah, I would be very surprised. I think it will still offer for protection.
Ma'am, can we take 2 more questions because many people are asking?
Yes.
Yeah, sure. So I will put Akash Chandlia's question because he can't unmute himself, and then Sunita, you can ask your question. So, ma'am, Akash asked, ma'am, as you quoted, we don't know whether the T cells and the B cells last for long in our bodies in the case of COVID-19. Then how do we know the vaccines will work? Because they also work by producing the same T cells and B cells. They are going to protect us against the virus in future, as I understand.
Well, we've not had time. So let me answer this and you can read the rest of the question. We've not had the time to see what is going to happen, right?